Lesson 829, Water Slide, Slope of Lines. In this lesson, we'll show that all slope triangles on the same line are similar. We'll also figure out the slope of a line using slope triangles. All right, we're on page 94 to start these very important notes that introduce a concept that you'll be using for the rest of your high school math career. And it's the concept of slope. Let's start by just defining a couple of goals. We want to show that all slope triangles on the same line are similar. Show that all, we're going to be calling them slope triangles. Show that all slope triangles on the same line are similar. Since seen similar triangles before. And also, we're going to figure out the slope or the steepness of a line using slope triangles. Figure out the slope of a line or the steepness of a line using slope triangles. All right, we're going to be using the word slope a lot, so let's get comfortable with what it means. Slope is really a way to measure the steepness of a line. In class, we talked about how they measure how steep a ski hill is, and we give it a picture like a green circle or a blue square or a black diamond, but all of those are based on steepness measurements. And those steepness measurements are just a ratio of two things. The ratio of a slope triangle vertical height and horizontal base. I'll show you what I mean. This will be better with pictures. So let's say we have a right triangle like this one. In all of our slope triangles, we're going to have a horizontal piece and a vertical piece. Okay. Sometimes these are called the rise and the run, but the rise is a vertical change and the run is a horizontal change. Vertical is up and down, horizontal is left and right. So let's talk about the slope of this line, how steep that line is. And let's say I know that in this triangle, to get from here to here, from the top to the bottom, the vertical change is maybe 2 feet, and the horizontal change is 3. Then the slope of the line is going to be the change in that vertical height, or the rise, divided by the change in that horizontal distance, or the run. And that number tells me something about how steep the line is. And we'll find over the next few lessons that the bigger this number gets, the steeper the line gets. Just one little thing that we'll need to preview for the next lesson is you can use coordinates of 2 points. Like if I knew these coordinates, I could figure out the vertical height and the horizontal height. You can use 2 coordinates to find the slope between those 2 coordinates, the slope of the line between those 2 coordinates. We'll find in the next lesson that the y values in the coordinates really measure the vertical change, and the x values in the coordinates really measure the horizontal change. But we'll save that for the next lesson. But you can use coordinates to measure slope. All right, so let's get used to this idea of rise over run and what we mean by slope triangles. So we're going to be looking at this line right here. I think I'm going to make it yellow. I want to find the slope of this line. And there's lots of little slope triangles connected to it. The slanty part of all these triangles is going to be on the line. We're going to show how the slope is calculated using the slope triangles between each pair of points. Now, all the triangles I'm going to be talking about are going to be similar. So the ratio of the height or the rise and the run is going to be the same for all of them. Let's start with these 2 points, points A and B, right there and right there. So if we imagine that this is part of a right triangle, I'm going to first look at the vertical distance between these 2 points. To get from A to B, looks like I'm going to drop down 2 units. And then the horizontal distance between these 2 points, it looks like 3. So the ratio of the rise to the run, that vertical distance divided by the horizontal distance, the rise was 2 and the run was 3. So the slope of this line is 2/3. That's the slope. Now, we're going to look at a bunch of similar triangles just to verify that no matter how big the triangle gets, the ratio is going to be the same. We actually learned that in the last set of lessons. Let's go on to 2 other points. I'm going to look at points D and B and measure the slope between those 2 points. So here's D, here's B. And imagine you're a skier sliding down this hill. Let's first ask, what is the vertical change going to be from B to D? Well, it looks like we're going to drop about 4 feet. And the horizontal change between B and D looks like it's going to be about 6 feet. I'm saying feet like we're on a hill, but coordinate plane, no different. Okay, so again, let's find the rise over the run in this green slope triangle. Now it's along the same line, so the ratio of these 2 things should be the same. All right, so in our green triangle, it looks like the rise is 4. And the horizontal distance, the run from D to B, is 6. So rise over run. Now, are these 2 the same? Well, let's reduce these. I'm going to reduce this fraction. Both of them are divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Oh my goodness, look at that. The slopes are the same, which makes sense because these are similar triangles. We're going to keep going just to make the point. Let's look at points A and C. I'm going to do this in a blue highlighter. Here's point A, here's point C. And it looks like this time we're getting a little busy down here, so we can go up and over just as well as go down and over. So to get from A to C, it looks like the vertical change, the rise, is 4. And from C to A, the horizontal change is 6. We always have to do the rise over the run. Rise is that vertical distance to find the slope. All right, so in this blue triangle, the rise is 4 to get from point C to point A, and the run is 6 to get from C to A, that horizontal distance. Well, it looks like we have just the same thing that we had with the green triangle. Similar again, I'm going to divide the top by 2 and the bottom by 2. And I end up with 2/3 again. And we're going to look at one last teeny weeny one. The distance between points A and E. Here's E, here's A. So one last time, we're going to find the rise, like how far do you have to travel to get from A to E or from E to A, up and down. The rise is 2/3, and this horizontal distance, the run, is 1 unit. So big finish. In this one, the rise is 2/3. I hate having a fraction within a fraction, but let's do this. And the run, the horizontal distance, is 1. Well, anything divided by 1 is itself. So once again, I can see that since all of these triangles are similar, the ratio of their corresponding sides is going to be the same again and again and again and again. All of these ratios were the slope of the yellow line. All of these triangles had that slanted side of the triangle sitting on that yellow line. So what do all of the right triangles drawn in the same line have in common? Well, they have the same slope. Because they're all similar triangles. So this is just an introduction to slope as the ratio of the rise and the run to get from one point on a line to another. All right, good luck having fun with the homework where you're introduced to slope.